Assalamualaikum dear students, welcome to the new lecture. In today's lecture we are going to study about mole and Avogadros number. Mole. When we go to a supermarket, we always buy things using standard values. In other words, we buy 1 kg of rice, 200 ml of fruit juice, and fruits are sometimes counted using a unit dozen. 1 dozen of bananas or eggs, that one this dozen means 12 of something. Pairs is for shoes and socks, while ream is for paper. These are terms that are used in our everyday life, and this shows that the counting unit depends on what we are counting. And let's suppose we are having a glass of water and we want to know the number of water molecules within this glass. We will probably say that it's practically impossible to calculate the number of atoms or molecules, but astonishingly, chemistry has an answer to this as well. And that brings us to the concept of mole. What does that mean? Chemists use a counting unit called mole, and this is used to measure the amount of a substance. But 1 mole, it is equal to 6.022 times 10 raised to the power 23 atoms, molecules or particles. Isn't this huge? If we write it in an expanded form, it would be like this. This shows if we are multiplying 3 with this number 6.022 times into 10 raised to the power 23, then it means we are talking about 3 moles of any substance. If we say or take 1 mole of pure gold, it means that 1 mole of this gold will contain this number of gold atoms. So, mole can be defined as the amount mass of a substance which contains Avogadros number 6.022 times 10 raised to the power 23, and this mole is represented as MOL. So, it can be seen that it forms a link between mass of substance and the number of particles that substance contains. The mass of a substance can be its atomic mass if we are talking about atom. It can be molecular mass if we are talking about a molecule, and it can be formula mass if we are talking about an ionic compound. If these masses, they are generally expressed in AMU, but when we are going to express them in grams, they are called their molar masses. Now, quantitatively, mole can be defined as it's the atomic, the molecular or the formula mass of a substance that is expressed in grams. Let's have a look at this example. Carbon 12, isotope of carbon. The atomic mass of this carbon 12 is 12. So, if this atomic mass is expressed in grams, it will be 12 grams. Now, this 12 grams means 1 mole of carbon atom. Similarly, water molecule and sodium chloride molecule. Previously, we already know that the molecular mass of this molecule water is 18. So, if this 18 is expressed in grams, it is 1 mole of water. Similarly, sodium chloride, which is an ionic compound, its formula mass is 58.5. This 58.5, when expressed in grams, this is its 1 mole. Coming towards our second topic, that is Avogadros number. previously we said that 1 mole is equal to 6.022 into 10 raised to the power 23 atoms, molecules or particles. But what's this number we refer to? Does it have a special name? Lorenzo Romano Emilio Carlo Avogadro came up with this concept. I know this name is long, so we will address him as Avogadro. As pair represents 2, dozens 12, and similarly Avogadro number is the term that is used to represent 6.022 times 10 raised to the power 23 atoms, particles, molecules, etc. Now, this is just a number to represent a quantity. Can we go to a shop and ask, give me Avogadro's number of chocolates? Yes, we can. The only problem is that the shop will not have those many chocolates and neither we will be able to carry them. This Avogadro's number is a number to represent quantities, but the number is so huge that using this in daily life is practically impossible. That's why this number exists, but we do not use it in our daily life. Then a question arises, why this number exists if we do not use it? So the answer is that the chemists that work with atoms, molecules and electrons and many such small entities uses Avogadro's number. It can be defined as these are the number of particles. These particles can be atoms, molecules or ions in 1 mole of any substance, and this is numerically equal to 6.022 times 10 raised to the power 23. Avogadro's number is represented as this Na. Now, what is the relationship between Avogadro's number and mole? As we said, if the mass of an atom or a molecule or any other compound is expressed in gram, it is its 1 mole. So 1 gram of hydrogen, it is its 1 mole, and this 1 mole is going to contain this much number of atoms of hydrogen. Similarly, the molecular mass of water is 18 gram. So 18 gram means 1 mole, and this 1 mole means it contains 6.022 times 10 raised to the power 23 molecules of water. In the same way, if we take sodium chloride, its mass is 58. If that 58.5, it is equal to its 1 mole, and that 1 mole will be equal to its this much number of formula units. Thank you.